Hi everyone, my name is K. Moneshwaran. Today I'm going to explain my project Adaptive Self-Learning Network Monitoring System, and my teammates are G. Adityan and S. Lakshmanan, and our team is guided by Dr. M. Nudal Srinivasan, ME PhD, Associate Professor, Department of ECE. Our problem statement is: in traditional intrusion detection system, the rules are static. Over time, the network traffic pattern will change, and that does not directed by the traditional intrusion reduction systems. And the alert fatigue, which is nothing but false positive alerts may occur. If that occurs, the network engineers need to analyze that alert and need to verify about that alert. And slower responses, it would take hours and days to update the rules of the intrusion reduction system and to respond to the alerts given by the IDS. Our proposed solution is adaptive self-learning network monitoring system, which is nothing but an network monitoring system which monitors the network and automatically learns from the real-time packet and then monitors the network to define which is an attack related packet and which is a normal network packet by. And it also utilizes the drift detection, which is nothing but if their network packets are flowing like regular and the patterns didn't change, it is good. But if the patterns of the network packages will change, it will direct that pattern and then relearn the pattern to maintain the accuracy of the ML model and produce good alert results to us. And it also direction aware, which is the inbound streams are neglected and only the data for data exfiltration, the outbound packet only monitored for a high rate to find is there any system uploading confidential data outside of the network. This is our literature survey. Paper title is ML based network intrusion reduction system optimized for cloud SVM plus XG boost with Crow search. The author is Haija. It is an IEEE paper which is published in 2023. Method used is SVM, XG boost and CSA. The limitations are hyperparameter tuning done offline, static model, no real-time adaptations. Our project is dynamic model which assembles weights online without offline turning cycles. Here the online means the local network packets are trained to the ML model. Two-stage deep learning intrusion reduction system LSTM AE for network security. This is another paper from IEEE which is published in 2023, and its limitation is high memory usage requires labeled data, no concept drift mechanism. So our project uses lightweight isolation forest and HBOS, which is histogram based outlier score, needs zero labeled data at startup. So we are not using a labeled data to find which is a normal packet and attack related packet. Intrusion reduction system with deep learning probabilistic clustering to reduce false alarms. It's an another IEEE paper, and the limitations are requires human expert review for high for cluster not fully. Our project is handles false positive packet by training itself again and again. And the fourth paper is Advanced Random Forest for Real-Time Intrusion Detection System, and it is published in 2024. It is a single model and batch retained, no concept drift, no auto blocking responses. But our project uses tri-model assembler, which is nothing but we use three ML models to detect it is a malicious packet or a normal packet, and drift reduction retaining, which is nothing but retrain our ML model based on the packets flow on that network currently. and automated IP table blocking. And we also have IP table blocking, which is if the criticality is higher, then the IPs will be blocked. And the next paper is CNN by LSTM for network intrusion detection, spatial temporal futures, which is issued in 2024, and it is high computational cost, not suitable for edge commodity hardware and static training. Our project achieved 1.2 to 1.6 millisecond latency on CPU and no GPU is required. Our project uses a four-layer pipeline, which is nothing but capture, flow tracking, assemble detector, and response engine. In capture, we capture the raw AF packets, which is nothing but packets in Linux operating system, and flow tracking. We take 5 tuple flows and 28 futures from the packet, and we feed the data to the assemble detector, which is we give the data to learn the ML model. The using the isolation forest ML model, the histogram based outlay score ML model, and online STG ML model to vote uh, the malicious attacks and differentiate from the normal attacks. And the response engine, which is nothing but if the packet is flagged as a malicious packet, then the IP table block the IP address present in the packet, and that log is stored in a JSON log file, and the alert is displayed in the alert console. This is our ML engine, which is tri-model adaptive assembler, which is nothing but we use three ML model with various weights, which is isolation for us is 40%, HBAs and online SDG is 30%. All these three vote a packet which is malicious, then the packet is a malicious. Or any two of these packets, any two of this ML model need to vote for malicious packet. These are all the attacks that our ML model will detect, which is nothing but the port scanning, data exfiltration, and denial of service attacks. We extract 28 features from a packet by volume, packet count, byte count, and other related packet features. And based on timing, we extract 5 features, and based on TCP flag, we extract 5 features, and based on diversity, we extract 3 features, which is unique destination port and unique source port, and features like that. And based on payload, we extracting 4 features, and based on protocol, we are extracting 5 features. So this is our project updation, which is in our version 1, the ML threshold is 0.50. Any 2 of 3 model redux it malicious, then it is malicious. But after our version 6 model, we deduct if the ML models, if the assembler score is above 0.65, which is a 65 percentage, then the attack is a malicious attack. So which reduces the false positive of considering a normal packet as malicious packet. And these are all the other differentiations from the version 1 to version 6. This is how the live detection console output look like. And the attack detection port scan, it is nothing but there is a port scan might happen, so we need to check that if there is any port scan is currently happening now. This is a live nmap scan done in our project to check the project is working. And this is the console output of the project, which detects a port scan from source from 10.42.0.12, and the confidence is 90%. And actually we are doing the port scan, and this is the output seen in the console. And after the port scan ends, it says the port scan is cleared. So we are at the end of the presentation, and thanks for listening to my project explanation.